Okay, can the online folks see the slides?
Yes, we can.
Thanks. Yes. Okay, next we have Fumiaki Toyoshima and his work on dispositional account of aging, which sounds really interesting. Yeah. All right, thank you.
So, do you hear me? Yeah. Thanks, Phil. Hello everyone. So I'm Fumiaki Toyoshima. I'm a postdoctoral researcher at the University of Sherbrooke in Canada. So today I'm going to present the work about aging that I've worked with Adri Vanto, who is there, and Jean-François Etienne. Right. It doesn't. Oh, okay. So first of all, aging is central to many domains, such as biology, medicine, and demography. And it's a very heterogeneous phenomenon. And for instance, in a classical text, Medvedev classified more than 300 theories of aging. And he said that aging exists in many diverse forms and variations. So that's why aging is notoriously difficult to define. And the problem is there's a lack of unifying framework for various theories of aging. And as for previous work, for instance, Lopez, Ortiz, and others proposed 9 hallmarks for aging, and they have been widely used in the aging research. But it has been also pointed out that they fail to constitute an explanatory paradigm for investigating aging. Then the goal of our work is to develop ontology of aging that can serve as a unified and interdisciplinary framework for investigating aging. Then to achieve this goal, we adopt the methodology to give an ontological analysis of the 6 defining features of aging based on the upper ontology, basic formal ontology, or BFO. Then by 6 defining features of aging, we mean functional decline, structural damage, and reserve depletion, cellular senescence, phenotypic change, as the increase of in the probability of death or disease. And for time reasons, in this talk, I focus on functional decline, structural damage, and the increase in the probability of death. Then let me start with homeostasis, because I think quite a few domain experts understand aging in terms of homeostasis. And homeostasis basically refers to the state of balance of an organism to survive. And I'll explain it in more detail later. Then homeostasis is important for aging. So why? Because very roughly, aging is part of life, and life is a matter of maintaining homeostasis while facing what we call a hostile environment, such as infectious agents. And more specifically, the loss of homeostasis is intimately linked with at least some increase of the probability of death. And the increase of the probability of death is a it's a defining feature of aging, because roughly when an organism ages, it tends to have a higher probability of death. Then we can elucidate a relationship between the homeostasis and the increase of the probability of death in 2 ways. The at least two ways. As the first way is about how far an organism is from the homeostatic state owing to some factors such as mutations and infections. So let me take an example. So suppose that you are quite aged, then each kidney, your old body, has lost too many nephrons, and in that case, you are far from the homeostatic states, even if the remaining nephrons can recuperate from insults. But the second way is about how efficient the organism is at correcting drift from the homeostatic state. So assuming that you are quite aged, that your kidneys still have a good number of nephrons, but then each nephron is insufficiently efficient at repairing itself. And notice that in some cases of aging, both phenomena can occur. And then we are giving a BFO basis ontological analysis with increase of the probability of death. Then, as for preliminary, I'll explain BFO very briefly, as BFO has been already mentioned in this conference a couple of times. And BFO is upper ontology that is theoretically underpinned by the so-called realist methodology. And its upper ontology recognized by the International Standards Organization. And it has been also widely used in the context of the open biological and biomedical ontologies, or OBO foundry. The OBO has been also mentioned a couple of times in this conference. Then this is an overview of the BFO hierarchy. Then in this talk, I'll focus on three categories, that is processes, functions, and processes, dispositions, and functions. Then as you see, the BFO has a top level distinction between contingent and occurrence, and the process is a subtype of occurrent. So for instance, blood pumping is an example of process. And among contingents, there are dispositions, and typical examples include the fragility of glass, that is a disposition to break when put with sufficient force, and the solubility of salt, such as the disposition to dissolve when put in a solvent, for instance. Then in BFO, a function is a subtype of disposition, and examples of function include the function of the heart to pump blood through the body. Then we take a quick ontological look at homeostasis and increase of the probability of death. So on the one hand, so according to the ontology for general medical science or OGMS, homeostasis is a kind of disposition that is a roughly speaking, is a disposition of the whole organism, regulate its bodily processes in some relevant way. And on the other hand, the increase of the probability of death is a process. And moreover, according to one analysis of probability, a process of increase in the probability of death involves a disposition to die that is associated with that probability. And then we can ask an interesting ontological question, that is, what is the relationship between homeostasis, which is a disposition, and the disposition to die? But it's an interesting question, but for now we leave it open. Then now we think we take a more detailed ontological analysis of the some defining features of aging, including the increase in the property of death, as well as functional decline and structural damage in terms of dispositions, functions, and processes in BFO. Then to achieve this goal, we focus on the causation and aging. Why? Because, for instance, the philosopher of biology, Lemoine, argues that a satisfactory definition of aging can be expected to analyze aging phenomena by determining cause and effect relationships. And we haven't developed a full-fledged theory of causation, but instead we take a dispositional approach to the causal input of aging, and it's based on the twin pillars. The first pillar is a dispositional approach to causation. So the underlying idea is that a disposition has a causal input to bring about some process. So for instance, consider fragility. So the fragility of this glass has a causal input to bring about the process of glass breaking. Then the second pillar is a function-centered approach to aging. And the basic idea is that among many phenomena, function decline is a key feature of aging. And here, let us remind you that in BFO, a function is a disposition. So by combining a disposition approach to causation and a function-centered approach to aging, so we'll propose a disposition approach to the causal input of aging. So then, what is function? Well, what is function decline at all? So first of all, it's a process, and more specifically, it has a participant as an independent continuous that bears a function, at least at the beginning of this process. And moreover, we can say that a function is a subtype of disposition in BFO. So it has a what we call the causal basis. So for instance, the function of the ear to detect sounds has as causal basis here in the ear canal. And also, I point out that function decline comes in degrees. For instance, a partial hearing loss and the total lack of awareness of sounds. There are two examples of function decline, but they come in degrees. Then now we are ready for analyzing the causal input of the increase of the probability of death. So let's suppose that this particular process of function decline causally contributes to this process of the increase in the probability of death. Then here's a visualization of our analysis of a brief analysis of this causal contribution. So on the one hand, this function decline involves some function, and this function, because it's a dispositional, this function has as some causal basis, let's say causal basis 1. And on the other hand, this process of increasing the probability of death involves some disposition to die, and this disposition to die has as causal basis some, let's say, causal basis 2. Then we can think that, causal basis 1 is part of causal basis 2. Why? Because thinking this way, we can analyze the causal input of the increase of the probability of death in such a way that causal 1 basis of function 1, when causal basis changes through a process of functional decline, then the associated probability of death increases. Now let us turn to another feature of aging, that is structural damage. So it's generally speaking, it's a phenomenon in which some physical structure deteriorates. An example includes the deterioration of the spiral structure of the cochlear inside the ear. And to put it more ontologically, it's a process in which some physical structure deteriorates. And we can then we assume that in the canonical case of aging, so structural damage causally contributes to functional decline. Then by assuming so, we can analyze the causal inputs of structural damage. So let's suppose that this process of structural damage causally contributes to this process of functional decline. Then this process of functional decline involves some function, and this function has as causal basis, let's say, some structure. And in this process of structural damage, this structure is being damaged. Now, finally, so we look at briefly the relationship disease and aging, because we are generally concerned with aging to prevent aging, so-called aging-related diseases, to improve the quality of life and to extend lifespan. But then, so the interesting question is, what is an aging-related disease from an ontological point of view? Then, so according to Ogmus, disease is a subtype of disposition. So it's defined as a disposition to undergo pathological processes that exist in an organism because of one or more disorders in that organism. And that means that a disease has as material basis some disorder in the organism. So it, for instance, epilepsy, so following the organism's conception of disease, epilepsy is a disposition that has as material basis clinically abnormal neural circuitry of the brain. Then there are multiple interpretations for the analytical relationship between disease and aging. And here's one interpretation then, whose basic idea is that aging-related, so-called aging-related disease is a result, in some sense, is result some what we call aging process, as illustrated by any of the 6 defining features of aging, such as functional decline and structural damage. And to concretize this interpretation, I introduced the Augunstam etiological process. So it's defined as a process in an organism that leads to a subsequent disorder. And the example includes toxic chemical exposure that leads to the mutation of the genomic DNA of a cell. And by using the Augunstam etiological process, we can think that some aging-related diseases have as material bases disorders that result from etiological processes that are either parts of aging processes or caused by those aging processes. Then let me wrap up. So we get so in this work we took we just take first steps towards the ontological aging that can serve as a unified and interdisciplinary framework for investigating aging. And for this purpose, we did a BFO basis analysis of the 6 defining for aging. And in this talk, I focused on functional decline, structural damage, and the increase in the probability of death. And so our work is theoretically, our work is characterized by a dispositional approach to the causal input for aging. Then this is the end of my talk. So I'd appreciate any comments and any questions from the audience. Thank you so much.
Thank you, Fumiaki. We have time for one question.
How do you differentiate from a fatal injury from aging? So my probability of death goes way up with a car accident and my aorta tears. How do I age all of a sudden in one instant, or is there some way to distinguish between the two?
Okay, good question. Okay, so you mean how can we differentiate ontologically between the increase of the probability of death associated with aging and that
with a severe catastrophic injury?
Yeah, that's a good question. We haven't. So in this work we haven't we are yet to reach that level. But yeah, So because in this work, for instance, in our paper, by the term functional decline, we mean functional decline that is associated with aging. So we are just assuming we just assuming that they are in some sense associated with aging. But that's a good question. So we will address in the near future.
Okay.
Yeah.
All right. Thank you. We'll move on to the next presentation now.